So my demonstration speech is going to be directed to students that are in sixth grade, which are actually doing some chemistry reactions, and some of them don't like it much, so some of them like it. So I'm gonna pretend to be a chemistry professor, also that teach sixth graders, and trying to make like look chemistry fun for them. So maybe they can the part that they don't like, they can enjoy them too. So here we go. Good morning, students. My name is Carlos Hernandez. I'm a professor, a chemistry professor also for sixth graders up in the South St. Paul Middle School. I heard that some of you don't like much chemistry. So I'm here, I was invited here to show you, to demonstrate you that we can have fun while we do, while we work in chemistry also. We're gonna do something called elephant toothpaste, okay? That's a nickname to the we're gonna it's been given to this, which actually in the fancy name is exothermic reaction, which is the creation of heat in the outside. So what we're gonna do is that we have some ingredients here, and I'm gonna show you pretty soon that we're gonna mix all together and do this exothermic reaction and have some fun with it while we're creating this mix of foam. So maybe we'll explain first what the exothermic reaction is. Exothermic means no, the outside. Thermic means heat. It's like so heat in the outside. And how we're gonna create this? You're gonna you see these ingredients here. Like how he's gonna do this? Well, let's tell you some examples here about exothermic reaction. One big example it can be when you see a rocket, for example, on TV, is going to space. You see that rocket that gets propelled as a launch to space by these rockets gets launched. You see that all those white plume, following the fire that helps the rocket to go to the sky. It's it's a thermic reaction right there. All those gases, that is full of aluminum oxide. It helps to propel the rocket up to space, and that creates heat at the same time. And the outside, another classic, maybe two more examples I can tell you. Now the winter is coming here. Now in the fall actually, you can go outside, have a bonfire. You burn the wood, and you see the wood. What gives you? The fire gives you heat. That heat we use to keep us warm. Also, those hand warmers that we use inside the gloves or inside the shoes, those actually is also exothermic reaction examples that we use like in every other day. Also, another one is for trains. When trains are like the first trains actually, the locomotives, they used to use this. They used to use these ovens. When you throw a shovel coil, you see maybe like in the movies or one cartoon sometimes, like Mickey Mouse or something. When my kids are seeing, like they see the conductor shoveling coils in there, so it gets more heat. It creates more gases, and the gases go through these pipes and makes the engine and the wheels go faster and faster, faster and faster. You see more plume and more smoke coming out of the top from the chimney of the train. So that's exothermic reaction. So it's the use of heat in the outside. The contrary of exothermic is endothermic reaction. And one big example of endothermic reaction is photosynthesis, for example. But photosynthesis is like it takes the heat from the outside to the inside. So it creates photosynthesis in plants, like it changes the colors on the fall, or in the body also too, they create like ATP, so to give us more energy. And which we take the food and creates the ATP. So there are some samples of endothermic and some samples of the exothermic. What we're going to do here is we're going to do the fun part. Okay, so now we have these ingredients here. Our main ingredients that we have is we have the hydrogen peroxide, which is one of the main ingredients here, and it's H2O2. So he has an extra oxygen in this thing. Okay, that we're gonna pour here in this bottle. We have an empty bottle, so we're gonna throw some in there. Let's see if we can pour a lot of it. I'm gonna have to take the cap out of this thing, make it quicker. So because I only was invited for 10 minutes. So let's see if we can throw some in there, see if it is, this is only 3%. So now if you make wants to make like a huge reaction, probably you can get a 6%. Oh, I forgot, before we use this, don't forget your goggles. We don't want this in your eyes and go blind, right? So now we use that. Now we're gonna use some dish soap. There's another ingredient. You can use any of dish soap, as your mama or papa that can help you out, and you throw some in there. Some dish soap, and we're gonna put some coloring. Just like you can use on your cupcakes or do cookies or Halloween cookies, anything like that. You throw some in there, like that. And we cover it, and we just mix it. We see it's already green, the blue, and it turned out kind of little green already. So that's a chemical reaction right there already, and we haven't done our experiment yet, not the demonstration yet. Now we have some yeast. This is another ingredient called yeast that we use to make bread. Again, we find this in our kitchens. So it's dry yeast. We open this. We're gonna put 1 teaspoon in this cup that has hot water on it. 1 teaspoon of that. And we mix. We mix it for a good 30 seconds. Now you can see now the water doesn't have to be like a super hot, but at least warm enough to dilate the yeast here. So we make sure that you mix it good so it doesn't have any crumbles in there. Okay, keep mixing. And what the yeast does actually is a catalyst. A catalyst is like a helper, which is gonna help us to take the extra oxygen from the hydrogen peroxide out of it. So like the molecules of the oxygen, you're gonna get inside of the bubbles of the foam and make the foam rise. So hopefully this works. That's one thing also with chemistry. Sometimes experiments don't go as we want, so we have to deal with it. And the best part of chemistry, you have to try it over and over again until it's almost perfect, or you have the results that you want. So here we're gonna mix this. Hopefully we have enough peroxide in there. I'm gonna put this down, so I'm gonna choke my head a little bit. And here we go. Hopefully it works. I said, maybe not, maybe we'll try it again. And we pour it. And you see the foam rise. And there we go. Now that's what we're creating foam and having fun at the same time. It's green, as you can see. And actually this can be, let's cover this before we make a big mess. And when we touch the bottle outside, we can tell that it's heat outside. The bottle is warm, we feel it warm, and that's called it's our exothermic reaction. We have created heat in the bottle, like we can use that, I don't know, to warm up something that you want, but also we create some foam. And this is washable and it's clean. So that's our demonstration for today, and hopefully you enjoy chemistry. Thank you.